So we proved the existence of a large mountain range that was present 600 million years ago. This large mountain formed when Africa and South America were together in a single continent, so-called Gondwana, and we found rocks from localities in Africa and in South America, and indicate that there was a big mountain chain running all across the region of the size comparable to nowadays Himalaya. And the mountain range has since been eroded, but while it was eroding, a large amount of sediment was shed down to the ocean to sustain the evolution of life.
This is a very simple model of how the continental crust floats on top of the mantle. As we can see here, the big peaks are supported by very deep roots. They have seen pressures that are 30 to 40,000 times atmospheric pressure. And under these pressures, we form special minerals that are a key. They are an indication that these rocks were once at these 100 kilometers depth. So what we then do, we go into our laboratory and try to reproduce the conditions in the interior of the Earth. Here we have these big presses that are able to produce the pressures and temperatures in the Earth's interior. So what we can do is we produce a very small powder. We put it in a capsule and then we put it at 30,000 to 40,000 times atmospheric pressure, temperatures of 700 degrees, and we let it cook for 1 week. During this week, we create our own small rock in the laboratory. We can compare then the chemical composition of what we produced in our artificial rock with the natural rock. And once they match up, we know the conditions at which both they form.
And to exactly know when our mountain form, in our deep rock form, we extract tiny mineral from the rock and we measure the composition using this large instrumentation called an ion microprobe. When the crystal form at depth, it contains uranium that over time decays to lead, and by measuring the amount of uranium and lead in the crystal, we can calculate the age. So we had to put together different pieces of the jigsaw by combining samples provided by our collaborator from Brazil with expertise and analytical instruments available here at ANU. And by analyzing tiny crystals, we could reconstruct the existence of mountains 600 million years ago.